Let's explore third-party libraries in this module. A concept which makes sure that we don't reinvent the wheel, because reinventing anything typically is not the best idea. So in this module, we'll have a look at what third-party libraries are and why you might want to use them in JavaScript, but actually in programming in general. We'll have a look at a couple of example libraries, and specifically, I'll also show you how third-party libraries, or one specific third-party library, can make working with HTTP requests easier. Now, we covered HTTP requests in great detail in the HTTP module, and it's important to know all of that, and using a library is not a must-do. Nonetheless, in this module, I'll show you an alternative, and you'll see why you might prefer this over manually implementing all the HTTP things you learned about. So what is a third-party library? That's, of course, very important to understand. We're working with JavaScript, and by the way, for the concept of third-party libraries, it absolutely does not matter if you're working with JavaScript in the browser or with Node.js, which would allow you to write server-side applications with JavaScript. Actually, the programming language doesn't even matter, because that idea of having third-party libraries does not just exist in JavaScript world, it's available for any programming language out there. Because the idea is the following. You are writing code for your application. That's your job as a developer. Now, when writing this code, there are certain problems you have to solve. In this dummy application here, we're building a toArray function which combines two numbers into an array. But then let's say we also want to get the difference between this array and some other array, which I hard-coded in there. Now that's just one example, of course, but it's typical for tasks or for problems you will face as a developer. You're working on some project, and for that you need to write a lot of code. Now, some of that code is really specific to that project, really specific to the business logic behind that project. But other functionalities, which you might need as part of this project, might be more like this type of problem here. You might need some utility function, because maybe as part of the business logic of your project, you need to get the difference between two arrays, let's say two lists of customers. But the comparison itself of the two arrays, that's a problem that's not specific to your project. That's a utility function you have to write, and therefore you have to spend time and energy on a task which is not directly related to your project. Now that's where third-party libraries come in. Third-party libraries are essentially packages of code, typically packages of functions written in JavaScript, which have all that logic in them, so that you can just reach out to these predefined, pre-written functions and functionalities and use them in your project. So third-party libraries are really all about adding utility functions of different complexities. Can be very simple, very trivial utility functions, or more complex functionalities which you want to add. That does not really matter. The idea is that third-party libraries can help you have an easier life as a developer, because they take away some of the complexity which is not directly related to your core project, to your core business logic, which you still might need. So let's have a look at some examples. Now for that, I have a project which you find attached, empty HTML file, empty script, and I want to start not with a third-party library, but with a functionality built into JavaScript, because the idea is the same, and that would be math random. You learned about this. This method on the math object generates a random number. Now you could come up with your own random function where you take the current date, let's say, and some other things into account to get a pseudo random number. Now, of course, math random is a bit more elaborate than that, but the idea is the same. You get a method here which you also could kind of build on your own, but you get it so that you don't have to build it on your own, because getting a random number is something you need fairly often in programming, but you don't always want to rewrite the code to generate that number. You want to write the code that uses the random number. And that's the general idea in programming. We want to write code that's exclusive, specific to our project, and don't reinvent the wheel for such common tasks like generating a random number. Now, in the case of Moth Random, it's built into the browser and exposed in JavaScript. And that's not the case for everything. Let's come back to that example where we have two arrays and we want to compare them. We have customers, let's say, where we have Max and Manuel and Anna. And we have active customers. And there we have Max and Manuel, let's say. Now, for our application, we need to find the difference. We need to find out which customers are, for example, in our database, from which we might have retrieved this array, and which customers are active, because we retrieved them from another database where we had a look at customers that placed an order in the last year. Anything like that could be what we're trying to do. So we have two arrays here, which of course might be longer, but to see what happens, I'm working with these short arrays. Now, because these arrays are short, to us humans, it's obvious what the difference is. But if they were longer, it might not be obvious. And in addition, this typically would not be hard-coded, but we might be fetching this from some database. So now we want to get the difference, the inactive customers. And that's basically the customers array minus the active customers. Now, customers minus active customers is not something that works in JavaScript. If we try to do that and try to log the result, you will see that if I load this page, we get not a number, because we're trying to do a subtraction here with two values which are not a number. So getting the difference of two arrays does not work like that. Instead, we need to write some function which basically goes through this array and then checks if this item is part of this array, if this item is part of this array, and so on. Now, we absolutely can write such a function on our own, but this is a typical use case where we might want to use a third-party package. And for this specifically, we could use a package called Lodash. You can just Google for Lodash. It's a quite popular JavaScript package, and you should find lodash.com. This is the official page, and there you find an explanation of what this JavaScript utility library is all about and how you use it. Now, this is a typical example for a JavaScript library and why you might want to use it. This gives you a broad variety of functions you can use to improve your code or to get certain functionalities. You can click on documentation to get an overview of all the built-in functions. And for example, there you'll see there is this difference function. And this indeed takes an array and then another array, and it compares that and gives you the difference of arrays. Here you see an example of how this function would be applied. Now, to use Lodash, we have to add it to our project though. We can't just call this code here. So if we try to execute this code, of course it won't work because we use this special underscore thing, and actually that's just a variable. You learned that variables can start with the underscore, and that's actually a variable which consists of nothing more than an underscore, but it is a regular variable therefore. But of course it is a variable which our project doesn't know because we haven't defined it, and it's also not a standard JavaScript variable. So executing this code here will not work. If I try to do it, I get an error that underscore is not defined because, as I explained, it's not a default variable. Now, it is not defined because Lodash defines it. Now, to have Lodash define it, we need to add Lodash to our project. Now, to include a library, we typically find installation steps, installation descriptions on the library page. Here, we find a bunch of different installation options. That also depends on how your project is set up. We'll have a look at how we can set up more complex JavaScript projects in the tooling module later. But you typically always can just download the script or use a CDN, and I'll come back to what a CDN is in a second as well. So here we need the full build, and we can click on this, and it will essentially open a JavaScript file here. You can just download this file or copy all the content in there. Here I'll just right-click on full build and save link as to download this JavaScript file, and I'll store it in my project folder here. Now by doing this, this Lodash.js file was added, and this now basically contains all the features the Lodash library provides, and we can just use that. Now that's one way of importing it. Another way is to use that optimized version. So I'll download this and save this link as it's lodash.min.js. And the difference simply is that this is now a script which contains the same features but is optimized. It's simply smaller in code because all the function names, which aren't important and so on, were shortened. And therefore, this is faster to load for the browser. Now, in a later module, we'll also learn how we can optimize our own code like this, because of course we don't have to write it like this to use it. So you can use either of the two. Typically, you want to go for the optimized version so that you have a smaller script and the browser has less to download. And now you just need to include it. So in index.html, you want to add another script import before your script import. And the order is important so that you import the library your script depends on before your script runs. Otherwise, your script will run too early and will search for features which weren't defined globally yet. So therefore, we want to add a script import here before our script and import one of the two Lodash files. Here, I'll go for the minified version and add the fur here because I got the fur on my script as well. And with that, if we save that and reload, now you see this works and we get an array of 1 as a result of this operation. Now, here we get 1 as a result because I'm comparing these two arrays. Now, of course, we can use customers and active customers here as well. And if we save that and reload, we get Anna, which indeed is the difference between the two arrays. So this is how we can add and use a third-party library. Now, I mentioned there would be one other way of adding it. Most libraries also support CDNs. Here you also find a CDN copies link. And this in the end gives you a link you can include so that you don't need to download the package, the file, and manually import it, but instead you have such a externally hosted file where you can import the external hosting link. Now here in the case of Lodash, this means we can just grab this link by clicking on copy URL here, copy to clipboard, copy URL, and then in your index.html file, you can replace your local import here, and I'm just commenting it out here so that we still have it for reference, with that CDN import. So here you then add a script where the source is this link. So now this is not hosted on your own servers. It's not part of your own project. We could delete these two Lodash files here, but we're getting it from some other external server. The advantage can be that this might even be faster. It might serving it faster than your own server because these CDN servers often are quite fast and you don't have to worry about downloading it and managing it on your own. So both is possible. You can go for either approach. Important is just that you do add it and that you do add it correctly before your script executes. And with that, as you see, we can successfully run this code. Now, Lodash is just one library, a very popular one, but absolutely not the only one. There are thousands of available JavaScript utility libraries for JavaScript in the browser, but also for JavaScript on Node.js. And as I said, this concept exists not just for JavaScript, but for all programming languages, you could say. In addition, the complexity of the library differs. It can be something like Lodash, which offers a bunch of utility functions. It can be something else which allows you to write JavaScript in a brand new way. There also are JavaScript frameworks, which are basically very, very, very large libraries, like Vue.js, React, or Angular. Due to their complexity, we'll have a look at those in a separate module, though. But we'll also cover this. These would be very big libraries. Typically, when you say library, you mean something a bit smaller, which focuses on one core task. In the case of Lodash, it focuses on giving you a bunch of utility features, and it is really good at that, typically. Another popular JavaScript library, for example, would be jQuery. It was very popular around 2010, 11, 12, and it still is heavily used, but it was more important in the past because jQuery actually made working with the DOM, adding elements, querying elements, way easier. Now, since then, since the early days of jQuery, JavaScript has come a long way, and nowadays it's really easy to work with the DOM, traverse the DOM, work with CSS classes there, and so on with native DOM APIs, which is why you don't really need jQuery as often these days, but you still might encounter it in a lot of tutorials and threads on the internet you find, and therefore you should be aware of it. It's a JavaScript library which you add to your project basically as you added Lodash by downloading it or by using a CDN, as you see down there. And then jQuery is not about giving you utility functions like getting the difference of two arrays, but it gives you a lot of functions that help you work with the DOM. And that can also be interesting, but again, as I said, basically all of that can nowadays also be done with the core JavaScript APIs you learned about in this course, so you might not need that, but you should be aware of it. Of course, seeing the examples of jQuery and Lodash raises the question, how do I know which libraries exist? Is there a page where all libraries are listed? That's not really the case. There is a page, npmjs.com, which is basically a repository of JavaScript packages, but it's not really a page where you would just go and browse around. That's not the core idea. This is more like a lookup resource if you already know a certain library, like Lodash, and you then want to get more information about it, and it's especially useful if you want to include it in a more complex JavaScript project, which you're managing differently, something we'll cover in the tooling section, but what we're not doing right now. But so this is not really a page where you would go and actively search for new, interesting JavaScript libraries. Instead, it typically works such that you have a certain problem which you want to solve, and you just Google for the problem. For example, JavaScript send HTTP request. We want to send a JavaScript HTTP request, and we don't know how that works. Or we know that it works with XML HTTP request, which is also what we find here, but we're not too sure how that worked. Well, typically, if you then browse around, and for example, you go to Stack Overflow, which is a great forum for discussing programming questions, we might get some ideas on how we can send a request. And at some point of time, somewhere, you'll find some alternatives to the native APIs. For example, here, jQuery is mentioned. Now, turns out jQuery is not just there to help you work with the DOM. Indeed, it also makes sending HTTP requests a bit easier. But if you search around a bit more, and maybe you read this blog post, and programming is a lot about reading and searching, you will learn about another library, and that would be Axios. And that indeed is a really popular library for sending HTTP requests. So your next step then should be to search for something like Axios.js. And here you find the Axios GitHub page. GitHub is a page, a platform where open source projects can be managed. So where other people can share their projects and their code, and you can actually collaborate there and work together on a project. A really great page. Now, most popular libraries, or basically all libraries, also do have a GitHub repository, so you can even look into the code of these projects if you wanted to. More importantly than that, at least if you're getting started, you can also find further resources there on the starting page. Here, for example, you'll learn how you can install Axios, how you use it, and a rough overview of what it is. And here, for example, you find a CDN link that would allow you to include Axios, and then you could use it to send HTTP requests. And this is how you discover new libraries and how you can learn more about them. There isn't a single page, but it really is, like a lot in programming, a lot about Googling, reading, and GitHub. GitHub is really a great resource to learn more about projects and especially to learn more about JavaScript libraries. Now let's stick to Axios here. Let's use that. Now, we learned about HTTP requests in the previous module. There, we learned how we can use XML HTTP request or the fetch API for sending requests. We built our own utility function that made sending requests and working with the response a bit easier, but still it was a bit clunky. XML HTTP request was clunky because of this onload thing and so on. And the fetch API was a bit annoying because of the error handling. Now, nothing too bad, you can do that, but the more complex your project might get, the more complex your requirements might be for how you want to be able to configure requests and so on, the more annoying it might be to manage your own utility function that wraps the built-in native HTTP functionalities. Now, you can absolutely do that, but you might reach a point where you don't want to do that. And therefore, back in that project from the last module, let's now use Axios. Attached, you of course find my snapshot of this project in case you didn't follow along. So in that project we worked on, we had the send HTTP request function, which we called from inside fetch posts and from inside create post. Now let's use Axios, and for that we first of all need to add it, which we can conveniently do with this CDN link here. So we're not downloading it, we're just using this link. Now if you wanted to, you could download it. For example, you can just enter this CDN link here in the browser without the script tags, of course. And what this does is it loads the JavaScript file, and you could grab all that code and put it into your own script file, into an extra script file, which you import. But here I will just go for the CDN. So with the CDN here, let's go to index.html and add it before our script import. So here I'll add that script import and add the fur, because we have the fur on our script import as well, to make sure that they execute in the right order. So now we have these two script imports here, and now we're ready to use Axios. Now you can always learn how to use a library on its official page, or like in this case, on its GitHub page, where you find examples and a description and an overview. Also, since it's open source, you could also dive into the source code here and explore that. Though, of course, depending on the complexity of the project, it might be quite complex to read and understand. It is JavaScript code in the end, though. So here, however, we got a good documentation. And to use Axios, we don't need to follow that step here. That is only required if you installed it differently. Since we use a CDN, we'll have a globally available Axios object. So here, I'll comment out this send HTTP request function, or actually we can leave it here, but I'll not use it anymore. Instead here, where I await send HTTP request when we fetch posts, I can use Axios. Axios is a globally available variable now. It is made available by this script import. That's why we can use it. Now, Axios is an object which has a couple of methods. For example, it has a get method to send a get request. It also has a post or a put or a delete method. Here we need the get method, and the get method doesn't want the HTTP verb, the HTTP method, because it always is a get request, so we can get rid of that. It only wants the URL. Now what does Axios then return? Axios always uses promises, so that's quite convenient. We don't have to manually promisify it. It uses promises out of the box. So this get method returns a promise, and therefore using await on it, async await, of course works. Now what we get back here is some kind of response object, and we probably want to find out what's in there before we try to get anything out of it. So let's console log response here in fetch posts, and let's then go to our project, reload this, and click fetch posts. Now posts are not getting rendered, and we get an error because we didn't adjust all code right now. But this is what Axios returns, and that's actually great. It's an object with the response status code, but unlike the fetch API, for example, it also includes the ready-to-be-used data. So we don't need to convert some streamed data into a snapshot, as we had to do it here in the fetch API. We also don't need to parse it from JSON to JavaScript data. Instead, we get that automatically converted snapshot data here as part of our response object on that data field. And that data field, therefore, in this case, is this array. So here in our code, where I get the response from Axios, I can just say list of posts is equal to response.data, because we have that data property on the response object, and that's it. Now, what happens in the case of an error, though, if we send this to an incorrect URL? Well, if we do that, so if I reload now and I click on fetch posts, I automatically get a nice error message here. So Axios also got me covered there. Unlike the fetch API and unlike XML HTTP request, Axios does not treat technically successful responses, which have a response status code though, as successful. Instead, it does the same thing we manually built here. It throws an error if we get a response that technically succeeded, so that was delivered without problems, but that has a 400 or 500 status code. Axios throws an error for such responses. So it does not just throw an error if we have a technical problem, like a network connectivity issue. It also throws an error if we have a technically correct response with an error status code though. So here we therefore get an error and we make it into the catch block here without any extra work, which is one of the reasons why Axios is so popular. It just works. Using the data is simple, working with errors is simple. So here we got our error message. We can also, for example, have a look at the error.response to look into the response that caused the error, because technically it's a correct response. So of course it has a status property, it has some data, and if we need that, we can get access to it with the response property on that error object Axios produced. By the way, if you're wondering how I know that, besides using console log to find out, you find such information in the official docs typically. So here, if we now save this and we reload, if I fetch my posts, I do get the response that caused the error, so that I can have a look at the response body in case it included additional useful information. So that's Axios for getting data. Now let me fix that URL and see whether that all works now. Looks good. So let's now make sure we also use Axios to create posts. For that, we want to send a post request, and therefore instead of send HTTP request, we can use Axios.post. Again, we don't need to specify the HTTP method because that will be set by Axios now. And it will now just take a URL and the data we want to submit. Now here, I don't want to send my forum data, but my post here, so this object. Now if we do that, let's add then here, or use async await, of course. Since I have async here, let's actually go for async await. So here, await, and get the response just to find out whether it worked. Here, I'll console log the response now. If we do that, let's save this, reload, and enter a new post. Does this work? And click add. And that's looking quite good. We get back a response with the 201 status code, and we see this is the data we submitted. So that works. And there is something interesting here. Besides this being very simple, we also didn't have to add any headers here. Please keep in mind that for the Fetch API and XML HTTP request, we manually had to add the application JSON content type header. Now, Axios does this for you. It takes the post here, which by the way also is not JSON but a normal JavaScript object, and for one, it then transforms this to JSON, but B, it also adds the header for you. And Axios doesn't always use JSON there. It actually is pretty smart. Here it analyzes the data you're trying to add, and if that's an object or an array, it assumes that you want to convert this to JSON. So it then stringifies this to convert it to JSON and sets the application JSON header. If we would add the forum data here, Axios would detect this as well. And if we do that, and we try to send some data, and we go to the network tab, we see that now the request actually automatically appended forum data, and the content type was also set correctly. So Axios analyzes the body you're appending and then behaves correctly to set the right headers and convert the data correctly. So that's, again, extra convenience you get from Axios. Now, to finish it all up, let's also make sure we handle a deletion. And for that, we can use Axios delete here. Don't need to pass in the method, just the URL. And therefore, with this added here, if we save that and reload, if I click fetch posts, and I then click on delete here, we see such a delete request is sent here successfully. So that's Axios. It's just one of many JavaScript libraries, just like Lodash. It's a very popular library. And when working with HTTP, it really is a great alternative to manually using XML HTTP request or the Fetch API. You can use these options, but the more complex your application gets, the more micromanagement you might need to do to make sure that these APIs behave correctly. Axios then might be a great alternative, which is simply easier to use. So libraries can be really useful. Axios was really useful. Lodash also is really useful here. Now still, there are a couple of things you should keep in mind when working with libraries. For one, keep in mind that, for example, Lodash here, if you add it like this, includes a lot of functionality which you never use. We only use the difference method here, and yet we still import all the other features as well. That means that users of our application will download all that code, even if we just use one feature. We can see the effect if we reload our page. You see the Lodash package here has 24 kilobytes. Now obviously that's not that big, but it's way bigger than the rest of our application. So that can be a downside. You're downloading way more than you might need, and that could slow down the initial loading time of your application, which matters a lot if your application primarily targets people in areas of the world with poor internet connection. So that's one thing to keep in mind. You might include a lot of overhead. That being said, however, it is worth pointing out that many libraries allow you to import them in different ways. For example, Lodash gives you a core build, which only comes with some of the features, which is way smaller. Or in more advanced project setups, which we'll also cover later in the course, you even have other capabilities of basically just importing parts of a library and then stripping out the parts which you don't need. This project setup is not capable of doing that, but we'll have a look at other project setups later in the tooling section. So you can mitigate this problem, but still it is something to keep in mind, also because not all libraries allow you to be as selective as I just described. In addition to that, you also want to make sure you're working with libraries which are secure and well maintained. Let's use Axios here. It's open source, which means everyone can view the source and everyone can collaborate. Now, typically when you want to work on the code and share your edited code, of course it's validated before it's merged into this code base, so you can't easily hack this library. Instead, open source typically actually improves code quality and security because more people are looking over it and working on it. So having open source is generally good, but you want to make sure that the library you're using is also actively maintained, so that if there are bugs that break your application, or security issues, which of course also are very important, that they are fixed in time. Now, an indicator for that, for example, is to view the last commit. This basically means when the code was edited the last time. If this is 2 years old, then it looks like it's not actively maintained anymore. 2 days, a week, a month, that is pretty active. You can also check the releases page on GitHub to find out how often new versions are released. And if that is fairly regular, let's say once a year, twice a year, then this also seems to be actively maintained. For example, Axios here had its last release on June 1st at the point of time I'm recording this, which is not too far in the past. You can also check out the issues here, and it's quite normal that every package which is popular has a lot of issues, to get an overview if there are any big problems, though the sheer number here shouldn't be an indicator. As I said, the more popular a package is, the more issues it will have. Not all issues here have to be real issues, let alone big issues. So these are some of the things you want to watch out for. You can also judge the popularity of a package by looking at the GitHub stars. Axios has a lot of them. If you also have a look at some other packages, some other projects on GitHub, you'll see that they typically have way less stars than that. So these are some of the things you want to consider when choosing a package. Why are these things important? Because for one, you of course don't want to add a package which might open up a security hole. That's very important that you don't do that. And in addition, even if it's not insecure, if it has bugs which are not getting fixed because it's not maintained anymore, then your application might break and all of a sudden the package you're depending on is not getting updated anymore. So your application is broken and now you have to find an alternative or write the logic which you previously used from the package on your own to make your application work again. So these are some considerations you should keep in mind. And with all of that in mind, though, there's nothing that speaks against using third-party libraries. They can really make your life easier, and in modern development, it's normal to use typically a couple of external libraries in every project you're working on. And that's it for libraries. As I mentioned, there are thousands of libraries, and therefore it's impossible to go through all of them. As you grow as a developer, as you work with JavaScript day to day, you'll encounter many libraries. It turns out you often just work with the same 5 or 6 popular ones, but if you have a specific problem which you want to solve, then as I explained, using Google really is the way to read more about the problem, and in that process you'll often stumble across libraries which you might want to have a look at with the help of GitHub to find out how they work, if they're actively maintained, if they're popular, and so on. And that's therefore then it. This is it for this module. This hopefully helps you use libraries and improve your projects, and it allows you to focus on your core business logic and not reinvent the wheel over and over again. This is a groundbreaking course section. We'll have a look at JavaScript modules, and knowing about JavaScript modules will, and this is really no exaggeration, change the way you write your JavaScript code or your JavaScript projects. It is a super important feature. It's natively supported by modern browsers, and in the next module, you'll also learn how to build up on that and make it work in all browsers. But let's first of all learn about it. I'm talking about JavaScript modules, a key concept that helps you organize your scripts and writing multi-file code. In this module, you'll learn what exactly I mean with modules and how that works and why we use that. And of course, then you will learn how to use it with many examples showing the different syntaxes you can use there. So which problem do JavaScript modules solve? For that, I opened up this project we worked on earlier in the course. You might remember, it's this project here where we can drag and drop items around, and yeah, we got this behavior you see here. This is the project we worked on earlier. It's quite nice and will not add any new functionalities there, but if we have a look at the app.js file, we can tell it's quite a big file. Quite a lot of content in there, right? Our entire application logic in the end lives in this file. The events.js file was just a dummy file for experimenting with events. We can actually delete that as well as the events HTML file. The analytics.js file was also just a dummy file which I loaded here dynamically with app.js. So the core application logic is really completely in that app.js file. Now we might want to split that. Why? To keep our code maintainable, to make it easier to work on it. Also, if you're working on a team, if you have multiple files, it's easier than if you're all working on the same file, because that is certain to break at some point of time. Even if you can add it on the same file at the same time, you'll certainly run into situations where you add something which a colleague then deletes accidentally and so on. So having multiple files helps you a lot when you're working in a team, but even if you're working alone, you just find stuff quicker if you have multiple files. For example, here, if I'm searching for the project item class, I have to scroll through the file. I might scroll too fast. Where is it? Here's the project item. It takes me some time to find that, and that can be annoying. So an idea would be to split this file such that all classes have their own files. That might sound like file overkill, but actually it is indeed the standard, the default for most projects to have one thing per file, one class per file, one big function per file. Maybe you have a file with multiple smaller functions, shorter functions, but typically it's one piece, one thing per file. And therefore here we could add a new subfolder to keep things organized and add a utility folder and maybe a app folder. We could drag and drop the analytics.js file into the utility folder here, and then we could create a bunch of new files in the app folder. So here in the app folder, we could add component.js file For the DOM helper, since it's a helper, we could create that in utility. There we could have the DOM helper.js file. We could then also add the tooltip here to app, tooltip.js. We could add project item and project list files in the app folder. So project item.js and project list.js. And thereafter, we only have the app class left here in app.js, and I think that is fine. Now, regarding the file naming, it's totally up to you. You have to find your style and then just stick to it. Here, I chose an uppercase naming style, or I start with an uppercase character, and then every word in a word has an uppercase character. You could also go for project dash item here if you preferred that. This is really up to you. There is no good or bad here. You just should be consistent. And therefore, I'll also rename this here to analytics.js, starting with a capital A. Now, of course, we have to refactor our code here. For example, analytics.js moved. So here, when I access assets, scripts, analytics, and so on, I should dive into the utility folder and there search for analytics with a capital A. Now we can also split the other code here, cut the DOM helper class, for example, and add that here into the DOM helper.js file. Also then cut the component class from the app.js file and move that into the component file. And so on. So do the same here for the tooltip, which I'll grab like this and move into the tooltip.js file. And for the project item, I'll move this here into project item.js. And last but not least, let's grab the project list here and move that out of app.js into the project list.js file. So now this is all reorganized, and of course the implication is that if we reload the app, it breaks. We can't drag and drop anymore. Well, we can drag, but we can't drop. We got an error here, and of course it breaks because we moved all functionality, but all these new files are not getting imported. Now, of course, we can add imports here, right? We can go to the index.html file and just duplicate the script import here. Now we have to watch out regarding the order though, because the scripts are parsed and executed from top to bottom. So we have to make sure we import them such that every file has everything it needs to work. So we should probably dive into the utility folder first and import the DOM helper, because that was at the top of our app.js file before, and I did try to structure it there such that everything that depends on it comes below it. So I want to import this first. Then we can dive into our app folder and there import component.js. And as a next step, import project tooltip. Tooltip was next. Then import project item and then project list. And now hopefully this is an order that works. If we save that all and reload, error message is gone, and that works. Now to show you what you can mess up, if I would import app.js first, then actually we again have that error. So some imports might depend on others, and therefore you can mess up your code. It depends on which features you need from the other files and when that code that needs these features executes. So whilst this does work, and we did improve our project because now we have one piece per file, and therefore all these files are actually way more maintainable and way more manageable. If we need to work on the project item, we can quickly find that. But whilst that did improve, our situation here in index.html get worse. Not only do we need to take care about the order, we also will need to add every new file which we create to that import list here. So we have to micromanage that list in the index.html file. We have to make sure we load all scripts that together build up our application. And for this still relatively trivial project, that is doable, but consider this to be a bigger project. Quickly, you're in a nightmare. And that's where JavaScript modules step in. If you have programming experience with some other programming languages, then you might know this approach of specifying import statements or references to other files directly in a file. So you could say, my tooltip here actually extends the component. So this tooltip.js file definitely needs access to the component.js file. This is a dependency we have. Now we fix or we implement this dependency currently by ensuring the order. For example, if I would switch tooltip and component, this would break because tooltip would try to use component before component is defined. So we have a dependency here. Project item, for example, uses the tooltip class, though only at runtime when this code executes, so we might be able to mess up the order here and still get away with it. Nonetheless, here we also have a dependency. So it would be nice if we could say, at the top of the tooltip.js file, for example, this file depends on component, and then we could remove this component import here, and tooltip would automatically import component when it needs it, so when tooltip.js runs, basically. And that can be done with JavaScript modules. So to show that, let me comment out this component import, and therefore, of course, the tooltip.js file breaks, as you learned. So now let's see how JavaScript modules help us with that. We can go to the component, and there we can add a special keyword that makes it clear that we're exporting this, so that this class should be available outside of this file. Because by default, and that's an important rule, as soon as we switch to modules, which we haven't done yet, but as soon as we do so, we will have locked files. Currently, where we import everything with normal import statements here, when I assign a class like this, when I declare it here, it gets added to the global object. So it's globally available and every other file can use it. As soon as we switch to modules, this will change, and then every file will be locked down. Its content will not be added to this global object. It will not be globally available. Every file will get its own scope instead. So how do we switch to modules then, and which keyword do we have to add here? The keyword is the export keyword. This is a keyword built into JavaScript, which signals to JavaScript that inside of a module, I want to make this class here available to other files as well. As I just said, normally that's not the case. With export, we can make it available. Now we need to switch to modules. And for this, we go to our script here, to our root script, which we always will need to import here, because there is at least one script which we have to import in the HTML file, because whilst scripts will be able to point at each other, we need one starting point. And to that starting point script, to that script tag, we add type and set this to module. So type module needs to be added here. This is understood by the browser and tells the browser that now this script and all scripts referenced by this script, currently there are none, soon there will be more, will use modules. So now if I save this, this alone won't do much. If I now reload, we got even more errors. And this is actually an important error which we'll need to fix. Where is this error coming from? What does this error even mean? Modules are a relatively new feature, and as you might imagine, since scripts can point at other scripts that should be imported, we have to be strict regarding security. We need to make sure that a script can't import a script from another page, which might be malicious. You might think, why would I add such code to my own scripts? Well, if you're using third-party libraries, then such a library might be compromised and might try to download files from other malicious files. This is why we have a cross-origin request policy, which basically means cross-origin, so cross-domain requests are not allowed. You're only allowed to download scripts from the same domain your page is running on. Now, the problem we're facing here is that we're serving this app with the file protocol. Remember, what we always did thus far is we double-clicked index.html in the Windows Explorer or in the Mac Finder. And this opens it up in the browser, but actually does not open it up as it would be opened if it is served by a web server. It just opens it with this file protocol, which simply just means it displays the content of the file and is able to execute JavaScript conveniently. Thus far, this wasn't a problem because a lot of features work just fine with the file protocol, but web server dependent features, like using this cross-origin policy, don't work there. This policy requires the page to be served from a real web server in order to be validated. And therefore, we now need to serve our app here, our page, through a web server and not through the file protocol. Now that sounds difficult. It sounds like we need to set up our own server, host it somewhere, maybe pay for it. The good thing is you don't. If you Google for serve.js, you should find this serve package here on npmjs.com. We had a look at npmjs.com in the third-party library module. And here, you get a basic web server which you can install on your system and run on your system. You don't need to deploy your page anywhere, don't need to rent any servers. It spins up a little server on your machine, works on Windows and Mac OS, and this server will serve your application. Now to install it, we need to install Node.js though. We haven't used Node.js in this course. I will have a Node.js section later in the course, but we also don't need to write any Node.js code right now. We just need to install the Node.js runtime on our machine because this serve package requires Node.js because that little server which it spins up is written in Node.js. In addition, Node.js will also give us a tool which we can use to install this tool here, this serve tool, on our machine. So we get two benefits at the same time. So visit nodejs.org and download the latest version of Node.js. At the point of time I'm recording this, it's 12, but that doesn't really matter. Simply pick the latest one. It should automatically pre-select your operating system. It is available for all operating systems. If it doesn't, simply go to other downloads and manually pick your system there. So once you downloaded it and walked through the installer, it's a normal installer, nothing fancy about that. You can run a special command to install this serve tool. Not this command, but a slightly different one. For that, open up your terminal or command prompt, which you have on your system. The path where you navigate to does not matter. And run npm install -g, which stands for global serve. On Linux and Mac, you might need to add a sudo in front of this to get the right permissions. On Windows, this is not required. Hit enter thereafter, and you might be prompted for a password. If you are, simply enter it. And now what this will do is it will install this serve tool globally. Node.js ships with its own package management system, which we'll have a closer look at in the tooling module. And this manages packages on a per project basis, but also on a global basis. And here we installed a global package, which is now available on our entire machine. So with that installed, back in our project, you can open up a terminal which is navigated into this project. So you can either navigate into your project with the cd command here, or in Visual Studio Code, if you go to View, you can also click on Terminal here, and this opens up a terminal, your default system terminal or command prompt, but built into Visual Studio Code and already navigated into your project folder, which is very convenient, of course. And now here with serve installed, you can simply type serve and it will automatically search for the index.html file and serve that through this dummy web server. So now this gives you the address you have to enter in the browser to view your project. In my case, it's localhost 5000. And if I do enter this here, I load the same page as before, and we get some errors because we haven't fixed all errors. But we're not getting this course error anymore because now we can use modules and this course setting which they managed for us behind the scenes. You can ignore that favicon error here. We don't have a favicon, hence we can't load it. We now just need to fix our modules and make sure we utilize this exported component. Important note, you should keep this serve process running. You can always quit it with Ctrl+C or Ctrl+D. But if you quit it, you can't visit your page here anymore. So you'll always need to restart it with the serve command whenever you want to continue working on the project. You can only visit this page here on this localhost 5000 address as long as this process is running. So now let's fix this, or let's work on that. We have our server. We changed this app.js file to be of type module. So now let's make sure we use this exported component, and we use it by importing it somewhere. Exporting it is one path, but that still does not make it globally available. It just means that we can now import the exported thing, and you cannot just export classes, by the way. You can also export functions, variables, constants, and so on, so that you can use the exported thing in another file. Here, the tooltip.js file is that other file, and to import something exported, we indeed use the import command. So we start with import, and we also need to tell JavaScript from where. So we add the from keyword, and then as a string, semicolon thereafter, a path, a relative path to that file. A relative path starts with a dot, and then dot slash means you want to look in the same folder. Dot dot means you want to go up one folder, which we could use to then navigate into utility. Or just a slash could also be used to have an absolute path from your root on. But that's a bit more typical to resolve in our heads at least. So therefore you typically work with relative paths. And here I want to import from component. Now you see I still got an error here. The problem is I am exporting something in component, in that component.js file, but you can export more than one thing in your files. Here I have only one thing, but that's not a technical limitation. So we have to tell JavaScript what we want to import from that file. And for that, we go to that place between import and from, and here you add curly braces. Now the error is gone at least. Now between the curly braces, you write the name, the exact name of what you want to import. And typically you should get auto completion here. If you hit Control space, it should suggest you this component in my case, this component class. So if I hit enter, this is added here. Of course, you could have also just written this manually. And now we're importing component into this file. Now this is good, but what's not so good is that our application will still not work if I reload. The reason for that is that we still load the tooltip file with such a traditional import. We need to add type module there to make sure that it can utilize module features, which is the export keyword, but also the import keyword. If we do so and we reload, this error is gone, but we get an error that component is not found. Reason for that is that in this path here, you need to add the extension at all times. And regarding the extension, some people like to name the files which are only imported MJS at the end. This is totally optional though. You can go with .js, .mjs. The M would stand for module, but technically here it makes no difference. So I'll stick to JS. The extension is important to be specified though, whatever it is. So now if I reload, this works and our application works again, but now we're using modules to express this relation between tooltip and component. And this improves our application because now it's also super easy to see which dependencies we have in this file. And in addition to that, we also don't have to worry about correctly ordering the imports here because the import is right in our JavaScript file. So of course, this was just the start. We got more dependencies, we got more files. Tooltip does have no other dependency as far as I can tell, but Project Item, for example, has tooltip as a dependency. Now, we can still work with multiple imports as we currently do, but actually I really want to switch to a module-only setup. So I'll comment out all these imports here, also the DOM helper, and I'll only leave the app.js import here as our root entry point. Now that, of course, breaks everything. And now we therefore have to switch to modules entirely. So let's start our way from the bottom up. Let's start in app.js because that's our entry file. This will be the file that is loaded first. What do we have in there? We're using project list here. So project list is a dependency of this app class in the app.js file. So we should go to the project list JavaScript file and export project list here. Now with that, we can go back to app.js and here simply import this. So we add an import of project list between curly braces from the app folder and there from project list.js. Now with that we make project list, we make this class available in this app.js file and therefore this line works again. So if we now save that, we'll see that we'll get a different error. Now project item is not defined. This error is stemming from project list and that makes sense. We're able to get the project list into the app file. So now the JavaScript code execution moves on to project list and tries to run all that code, set up this class, and it of course will see that project item is simply not known to this file because this is a dependency of project list which we're not stating yet. So let's go to project item and as before export project item and then go to project list again and import it. Import project item from, and now it's in the same folder, so just / project item.js. If we do this and we save that, we get a different error. Project item doesn't find the DOM helper. So let's go to project item, make sure we import the DOM helper by first of all going to the DOM helper, exporting it, and then here, let's go back to project item, and in this file, import from, go up one level, go into the utility folder, then DOM helper, and here I want to import the DOM helper class so that this is available in project item. I also already know that I'll need the tooltip, so let's go to tooltip.js and actually export the tooltip, and you can have an import in a file and an export at the same time as well. We already did this in project list. This is of course absolutely okay. And here I'm exporting the tooltip. Now in project item, we can therefore not just import the DOM helper, but simply in a new line, add another import from another file. So here import from the tooltip.js, this tooltip class here. And if we do that and we save this and we then reload, we just got an error regarding the DOM helper. Yes, because I forgot .js here. Let's fix this in this import. Let's now retry. And now this works again, but if I drag and drop, I still get an error that in project list, I also use the DOM helper. So I forgot to import it there. So let's switch over to project list.js. This, by the way, also shows the advantage of having multiple files. It's super easy to find the failing part. And here we can also import DOM helper from the utility folder and then DOM helper.js. So let's save that, make sure all files are saved, and then reload again. Try switching this, and it works. So this is now how we can use modules. Now there are more features related to them, but this is the starting point. It's super important, of course, because this really allows us to structure our code in a more readable way, and every file defines its dependencies on its own, so that you don't have to micromanage imports here. Now regarding modules, there are a couple of alternative syntaxes, and I want to show you which syntaxes exist. Let's say we have more than one thing which we want to export. Here in the DOM helper, I only have the DOM helper class. Now let's say we would not have that class as a wrapper, but we would export two individual functions. We could just copy these functions, remove static here, and instead add the function keyword, for example, and we'd be good. These are two functions, and we could have created them as function expressions with, for example, arrow functions stored in a constant as well. Now these functions can also be exported by adding an export keyword. You can export everything, functions, classes, constants, variables, everything which you use in your code like this. So now we export these functions, both of them, and still also the class. And that's absolutely fine. You can export as much as you want. Now in project list, where we need the DOM helper, down there, I'm using move element. Now we also now export a move element function, this one here. So I could also just use that. So in project list, we could remove DOM helper dot and just access move element, but of course this would fail because we're not importing it. We're referencing this function, but it's not getting imported anywhere. Now you might say I am importing from DOM helper, but imports don't work file-wide. Instead, you really have to specify what you import. And here we're importing the DOM helper class, not the move element function. So therefore, if we save this, our code would fail. As soon as I drag and drop, we get an error that move element is not defined. So just importing from a file is not enough. You need to be specific what you import. You don't import the entire file content. So here the solution, of course, would be to switch DOM helper, which I'm not using in this file anymore, to move element. And now I'm importing that function, which I'm referencing further down below. And with that import added, if we now reload, this works again. So this is important to know, that you have to be really specific regarding what you import and that you can export more than one thing. You also therefore of course can import more than one thing. If we would still need the DOM helper class in here, we could simply separate it with a comma and then import it as well. And now we're importing DOM helper and move element from the DOM helper.js file. We're not importing the clear event listener function, for example, though. That's not happening. So we're very specific about what we need, and we specify it in a comma-separated list here in our import statement. Sometimes you do want to import everything that's in a file. Let's say here in project list, for some reason, we want to import this clear event listeners function as well. Obviously, we can do it like this, and there would be nothing wrong with that. For a lot of reasons, you might want to do it like this. But maybe you want to bundle all these things which are getting exported by this file in one object, which you then have available in the project list.js file, on which you can access these different exported features through the dot notation. And that is possible with a special syntax. If you have named exports like we do have it here, so you have multiple export statements in front of something, then you can go to the file where you import that and remove this curly brace list here and instead add a star. And then you also add as and then any name of your choice, like DOM H for DOM helper or DOM help or whatever you want. Any name of your choice here, doesn't have to be the file name. And what this tells JavaScript is that you want to bundle together all the exports of that file into this object. And now in this file, in the project list.js file in this case here, you can and you have to access this bundled object with the dot notation to then access the DOM helper class, for example, or the two functions. So now this looks like you're using an object with a move element method. Instead, we just bundled all exports of the DOM helper file together into one helper object, which exists in the project list.js file, so to say. So this is an alternative which you can use if you prefer that for whatever reason. This is how you can bundle multiple exports together and then access them through this helper object in the importing file. This as notation can also be used in general to assign new names. Let's say, still here in project list, for some reason I'm not happy with project item here. In project item.js, I named it project item, but I don't want to use that name in project list. Maybe because I would have a name clash, maybe we have some other element, some other constant or class named project item in this file, which we don't want to rename for whatever reason. So this would result in a clash, for example. Whenever you have something like this, you can also assign an alias to this imported thing. You can use the as keyword here inside of that curly brace list and assign a new name to that exported and here imported element, which will only be relevant in this file here. So here we could name this to purge item, for example. And now inside of this project list file here, we have to use this imported project item under this alias. So now in all the places where I create a new project item, where this is the only place, I have to use purge item instead, my alias. Now, of course, this does not change the name in the original file. It really just is an alias in this file. So with that, if I save that and I reload, we should still have the same behavior as before because we haven't changed anything about that logic here. It's really just an alias which we assigned here. Now, one last important feature regarding the export-import syntax we saw here. If you have one core element which is exported in a file, or maybe the only element which is exported, like here, component is the only exported thing in component.js, then you can absolutely export it like this, but you can also name it the default export of this file by adding default here, this keyword. You can then even omit the name here because you'll now not import it by name, but by just pointing at that file, and then automatically the default export will be picked. And I'll show you how that pointing works in a second. Now you can still have named exports along that. So here, if I had the do something function here, so export function do something, which actually does nothing here, then I could do that. We could import this by name and this as a default, which now just leaves the question, how do we import something as a default? Well, we're using component in tooltip after all. And this import would now fail. If I save everything and I reload, we would get an error because, as the error message says, component.js does not have an export named component because I removed that name. And even if I would add it, by the way, and I reload, it would still fail because we export this as a default, in which case JavaScript will ignore the name. So how do we now tell Tooltip that we're interested in the default export of component.js? Very simple. You just use a syntax you already saw before. You just say import anything, any name of your choice, like CMP, or of course all the component, but doesn't have to be the exported name or the file name, can be any name, from file. And then here we could use CMP instead of component. This tells JavaScript that since you don't wrap this in curly braces, this should be the default export of that file. And of course, therefore, this syntax only works if a file has a default export, otherwise it will fail. So now with this line, we import the default export of this file, which in this case is this class, under that name, which is totally up to you. You can use this feature. It has the tiny disadvantage that since you have to rename it when you import it, if you're working in a team, every team member might have his or her own naming convention, and you might end up with code which uses different naming conventions. And therefore using named exports, where you're all forced to, well, settle on some name, might be better. Nonetheless, it is a feature which you can use, and if you now would want to import that named do something export, you would do that by simply combining this with a comma with a curly brace list of named imports. So here I could import do something. So you can have a default and non-default, also called named export side by side, and therefore of course you can also have them imported at the same time. This is the default export, and here you list all named exports. So all the things where you just added export in front of them without the default keyword. Also, of course, important, should be self-explanatory though, you can only have one default export per file. You can't have more than one. So that's the JavaScript module import-export syntax. Now, if we have a look at our project, we can see something interesting if we go to the Network tab. If I open that and we have a look at the HTTP requests here, if I reload this page, you see we get a bunch of requests here because we're using a bunch of files and they are getting imported when our app starts. Because what happens, well, the HTML file gets loaded and there we request the app CSS file and the app.js file. Therefore, logically, first the HTML file is loaded. That's basically what's hidden under localhost here. Then the CSS file, then the JavaScript file. In the app.js file, we refer to project list. Therefore, it makes sense that the next item in the list here is project list, which is getting imported. And so on. So this is how all these things are getting imported. Now, obviously, we're sending a lot of HTTP requests here. And for a small project like this is no problem. For a large project, this is not that great because even though the files are all small, sending a request, getting the response, and parsing the response always has a bit of dead time, which is always there, which you can't get rid of. Network latency, the browser getting started, it's time which you can't get rid of. So the more requests you send, the more of that dead time you accumulate. And therefore, having hundreds of modules would not be a great idea because you would import hundreds of files and you would send hundreds of HTTP requests. This is a problem we'll get rid of in the next course module, in the next course section, when we have a look at tooling and at a concept called bundling. One other improvement which we could add here is also that some features are not always needed. For example, the tooltip. The tooltip here, this JavaScript file is loaded because we might eventually show a tooltip. But unless we click this button, we don't really need the file. Of course, it's a small file, but in bigger applications where you have more logic in your files, that can add up. In addition, the tooltip file is the only file that needs the component, so actually we have to add the two together. So if we would only load these files when we need them, we would speed up the initial page load because we would request less files to be downloaded and parsed. And that's also something we can do and something we can do in this module already. So to load modules conditionally, we can use an alternative import syntax. The import syntax you saw thus far at the beginning of the page is the static import syntax. It statically defines the dependency of a file. As an alternative to that, you have the dynamic import syntax. And for some scenarios, like the tooltip, where you know that the code will not always be needed, it makes sense. If you know something always needs to run, like for example, project list, which is imported in app.js and which we need right at the start to construct our lists, there it makes no sense to load that dynamically because you'll always need it. But for the tooltip, it can make sense. In project item, I need the tooltip here if we click on this show more info button. So therefore, instead of importing tooltip up there, statically, which means it will be downloaded when the project item file executes, I can also just download it here and request it here. How? With a special syntax. We can call import as a function and then pass a string with a path to the file I want to import, in this case, tooltip. Now this import function is built into the browser and exposed in JavaScript, and it gives you a promise. So you can add a then block here or use async await, of course. Now here you get your module in the end. And now in there, we can run code that requires the module. So in this case, this code which wants to attach our tooltip and create it and so on. So cut it and move it into this then block. Here we can now access module.tooltip. I know that we'll have a tooltip in this file, so I can access it on module. It is simply a property of this module object, so to say. And now this will only reach out to this file. We should add the extension though. It will only reach out to this file here when this code here runs and not at an earlier point of time. So now if we save that and we reload, you see we get no error, but in the network tab you see the tooltip and component.js files are not getting downloaded initially. If I click on more info though, then you see these two requests are being added and are being sent. But that happens at a later point of time, not when our app loads, but only when we need the code. This can be a huge improvement. Of course, you don't really feel it for such small files, but for larger files, not having to download them initially, but only downloading them when you need them can really speed up your startup time, which makes your app faster and more responsive when it first loads up. And with that, we're almost done. Now, one important question might remain though. When you're working with modules and you have some code that runs inside of the module file, so which is not a class which you define on export, but let's say here in project item, we have a console log statement saying project item created. Is this code executed or is only exported code executed? Well, let's find out. This is my console log statement. Here's my console. If I now reload, we see that output. So code in your modules runs when the module is imported and loaded for the first time. And that's important, for the first time. If you have a module which is imported multiple times, like DOM helper, which I import in project item, but also in project list, then it still only runs once. So if I go here into my DOM helper class and I add console log here, DOM helper executing, we'll see that this only gets printed once, even though we import from this file twice. But it only runs on the first import, so to say. So if I reload here, we see DOM helper executing, but it never runs thereafter. What if we have some code in a dynamically loaded file, like tooltip, which we just dynamically loaded? Well, let's output something here, tooltip loading or running, whatever you want. Let's output this here. Let's reload. Of course, we see no output initially because the file hasn't been loaded. If I click on more info, we see this, but only for the first time. If I click on more info thereafter, it does not run again. So code in modules does execute, and of course, sometimes you want that, you need that behavior, but it only executes once when a module is imported and used for the first time. Now, before we quit, one additional word about scope. Now, you learned that you can only use in other files what you export in the files you want to use the features from. So if you want to use that tooltip class, because we're using modules now, we can only use it in files that import tooltip, which is why we export it here. If you wouldn't export it, you also couldn't import it. Now, the global object, which we abused sometimes earlier in the course, therefore doesn't exist like this anymore. If we define something global here in app.js, let's say, which is the first file that runs, default value max, something like this. If we want to use that in another file, it's not that easy. If in project list I want to output this, well, let's try. If I console log default value here, make sure I don't have a typo. Let's copy this here, use it here. If we try that, you'll see that if we reload this, we get an error that default value is not defined. So it's not exposed on this global object anymore. Now we do have access to window though. If I console log window here in project list and comment out default value and save that and reload, you see this window object is still output. Now that's quite important because what we saw earlier in the course is that window is kind of a global object where some of our variables end up on when we define them globally. We could also access window with this in the past by just logging this here outside of a function. However, here in modules, this gives us undefined. So modules also run in strict mode out of the box. So in strict mode, you learned this gives you undefined and not the window, and that's the same here. Now, why am I showing all of that? Because it's important to know that, and because in the past, when you define a global variable like this, it would invisibly automatically be added to the window object, which acted as a global object that spans across your entire app, so to say. This was JavaScript's way of sharing data across files, you could say, by having that global object which every file can automatically use. Now this window object is available if we target it with window, but not with this. So modules have their own scope. Something defined in a module is not shared with others unless you export it, and this does not point at window. Now what you can do is you can add something to the window object like this as a property which is added dynamically and then use it. Now if we try to access window.default value here, however, it will not work because this code will actually be executed before this code runs, because here I'm importing project list. This is the point of time where the code in project list runs, and therefore this code where I want to read from window runs before I set default value. Now switching the order is not an option. This is not allowed. If we try to do that, we still get undefined because imports are automatically sorted to the top. So this will not work. To still simulate that sharing data across window works, we can just move this into, for example, connect droppable, which will be called at a later point of time because this executes when the constructor of project list runs, which happens when we create a project list here in app.js, which is the case after we stored default value in window. So now if I reload, we see max being output here. We see that twice because I'm creating two project lists. So the window object can be used to still share some data globally on your app. You need to explicitly add something to window, but then this is an option, a hack around the otherwise scoped data, so to say. And hence, you should really just use it as a last resort if you really need to share some global data and for some reason exporting and importing is not an option. Otherwise, don't do this. Now, besides window, however, you also now have another identifier, and that's global this. We haven't seen that before. As the name suggests, it's basically an alternative to this, which points at some globally available object. The idea is also that this is available both in browser-side JavaScript and Node.js-side JavaScript. The window object is not available in both. Now, global this can be used to store data, and in project list, of course, then also to read data. So here I can also reach out to global this. Now, if we save that and reload, we get the same output as before. The more interesting part, therefore, is what's inside global this besides our custom value. So if I just output global this in project list and I reload, you see it's the window object again. So in the end, global this in modules replaces this as your pointer at the window object. Because this inside of modules is not defined, it's just what it is. They run in strict mode, and there this does not point at window, but we got global this as an alternative. And an extra benefit is that global this will also work in Node.js. So you can always use global this everywhere, and you're guaranteed to not get undefined and point either at the window in the browser context or at another global object created by Node.js in the Node.js context. So it's a little bit of extra information. Often that will not be too important because you should really use exports and imports to share data. The key takeaway is that data that's not exported and that's not shared like this with this hack is not available outside of this file because you got a special module scope which ensures that anything that is defined on the top level of such a module file stays in that file. And this is it for modules, an extremely important feature for serious JavaScript projects. Having all your code in one file quickly makes it hard to maintain and read. Having manual imports in the index.html file, on the other hand, means a lot of micromanagement, and it can easily become an error source. With modules, which you unlock by adding type module and by using a web server, even if it's just a dummy one for development, with modules you get rid of that, because there every JavaScript file states its dependencies and has its own import, so to say. Now you can only import what you export with the export keyword, either with such a named export, where you just throw export in front of your class, function, constant, or variable, or with a default export, something you can also do and which we did in the component.js file, for example. You can have both named and default exports in the same file, and when it comes to importing, you also got a lot of flexibility. You can import named exports without or with an alias, you can bundle all exports together, or of course you can also import default exports and named exports at the same time. Last but not least, we also had a look at the dynamic import, which can help you split your code and download things only when you need them instead of in advance. And that's it for modules. Modules are a core feature, and in the next core section we'll build up on this knowledge and see how we can improve them even more. We've ventured pretty far into JavaScript land, and the more and more we learn about JavaScript, the more and more we see that projects, browser-side projects using JavaScript can get complex. For example, in the last module, we learned about JavaScript modules, which basically means splitting our code across multiple JavaScript files, where the files then import each other. Now there we could already see a huge advantage of this approach. It makes our code more manageable, but we also saw a disadvantage there. We had a lot of HTTP requests because all these separate files had to be downloaded one by one. And the bigger your project grows, the more this might become a problem. Therefore, in this module here, we'll have a look at JavaScript tooling, which essentially is all about managing our project with certain tools that automatically optimize our code, combine our code, and get out of our way when we are writing our code, so that we can write our code in the best possible way and still get an optimized and better output than we're currently doing it. So in this module, we'll have a look at what exactly we do there and why we do that, which tools we use and which tools we can use, which tools are popular, and I will also walk you through an example setup where you will see how to work with these tools to get this optimized project. Now, for that, I'm back in the JavaScript project we already worked on in the last module where we introduced these multiple files. It's the good old project manager where we can drag and drop projects with our different files here. And therefore, as I explained, one issue we have, especially if this would be a bigger project, is that we have multiple HTTP requests here. And the more files we add, the more requests we have. And since every request comes with a little bit of overhead, even if the file is pretty small, it can still be annoying and slow down our application if we have to download thousands of files. So we might want to avoid that. And that's exactly where tooling can help us. Actually, we are already using one tool, this development server here, which we had to use in order to get certain features to work. Now, that's pretty cool. This already shows us one example of an extra tool we need to build proper applications with JavaScript. We needed this development server to have a more realistic testing environment, where we actually serve our web page as if it were served by a web server somewhere on the internet. Previously, we just double-clicked on our index.html file, and that therefore did use the file protocol. Good enough for many things, but with certain limitations, as we saw when we started to use JavaScript modules, where all of a sudden, for security reasons, the file protocol was not supported and we needed a real web server environment. With that development server, we have that. So this is already one example of an extra tool we can use to have a more realistic development environment and to fully use all the things we can use with JavaScript. It's of course not the only tool though. To understand which tools we might need, let's dig into the potential limitations we might face with basic JavaScript projects as we use them thus far throughout the course. For example, we might need to micromanage all our imports if we're not using JavaScript modules, or if we are using them as you saw, and as I just explained in the last lecture, we might have a lot of unnecessary HTTP requests. So that's one problem we have. Not ideal. The bigger our project grows, the more we have to manage imports or live with all these requests, or both at the same time. Another problem we might face at some point, which I briefly touched on in the libraries section of this course, is that our code is not really optimized. It's not as small as it could be. Now, thus far we haven't built huge applications in this course, but we've certainly written some code. Now, when we write code, we of course use function names, which are pretty clear. We use variable names, which give a clear hint about what's stored in there. We use a lot of extra white space to structure our code. Or put in other words, we're using a lot of features that make the code more readable to us humans, but which are not important to the computer. If we would strip out all these features and ship as small of a code bundle as possible, we could load our page faster because the computer, the browser, has to download less bytes. If we would use shorter function names, then there are less bytes to be downloaded and therefore, well, the site loads faster. But of course, to us humans, if we use very short function names like A, B, C, D, well, that would be hard to understand our code. So that's something where a tool might be able to help us. Another potential problem we'll face, and I'll dig deeper into that in a separate course section actually, is browser support. Now, as I just said, I do have a browser support section in this course where we take a closer look at this. Generally, the problem is that we of course want to use all the latest and greatest JavaScript features when we write code. Well, the problem with that is that not all these latest and greatest features are supported by all browsers. So in an ideal world, we can write code that uses all these latest features, and we can ship code, which means we can upload code to our web server that actually is a bit older, so that works on more browsers, so that our modern code is maybe automatically translated to older code. Would be amazing if we had a tool for that. We also, when we write code, when we work on our application, constantly need to reload the web page to see our changes in effect. Wouldn't it be great if we did not only have a development server, but actually a development server that automatically reloads the page whenever the code changes? That would be amazing, right? It can really speed up your development time, your development flow, if that happens, if you don't have to manually press that reload button all the time. So that would be another improvement. Having a development server, which we already used, but one which is a bit smarter. And last but not least, something we haven't really done thus far is checking our code quality. Now, code quality is a broad term. There are certain conventions which you should follow, but there also are a lot of loose rules or a lot of ideas on how you could write your code. There isn't a single right or wrong way of writing code. Still, you might want to be consistent, so it might be interesting if you could configure your code for yourself and then automatically check it if your code follows the rules you set up for yourself to ensure it is properly written and has a good quality. So now we know about the limitations, the problems we might want to solve. Now it's time to solve them. And for that, we can use various tools which thankfully were created and do exist. So let me walk you through the different problems we're trying to solve, which tools can help us with that, and why exactly we use that tool. Important, for most of these tasks, we have more than one tool out there. I'm walking you through the most popular and commonly used ones here. Of course, you can always search for alternatives on your own then and find out if an alternative somehow suits you better than the option I'm giving you here. Now let's start with the development server for that. Now, the idea here is that we can serve our application under more realistic circumstances, but also, as I just outlined, maybe that we can auto-reload the page. Now, for that, thus far we used serve, and that did not auto-reload the page. Now, there are multiple alternatives to serve out there, but one particularly interesting one is the Webpack Dev Server. And I'll come back to why that is so interesting in a second, because it's closely related to the second problem we want to solve. We need a bundling tool. The idea behind a bundling tool is that it analyzes all our imports and exports which we have when we use JavaScript modules, and that it then combines these different files into a single bundled file or into a couple of file bundles, so that you don't have these dozens of HTTP requests which need to be sent, but that you can write your code split up across multiple files, which makes it easier to use, but that the code then, before you upload it somewhere, is actually merged back into a single file so that you have the better development experience, but ship code which requires less HTTP requests. And here, the by far most popular tool is Webpack. Now, Webpack, of course, is related to the Webpack Dev Server. That simply is a development server that is particularly easy to implement inside of a Webpack setup. And I'll walk you through such a basic Webpack setup in this module. So now we can bundle our code, we can serve our code. We also typically want to optimize our code when we ship it or when we build it for production. So when we're ready to deploy it onto our real server. During development, you typically don't really care about such optimizations. They might even be bad because your code might be harder to debug in the development tools if all the functions were renamed and so on. But when you're ready for deploying it, then you want to optimize your code. That means you want to shorten function names, remove excess whitespace, remove everything which doesn't break your code if you remove it. And for that, again, Webpack fortunately already has a couple of plugins built in which we can utilize to automatically optimize our code once we're ready to deploy it. Now that's the optimization. We also might want to write modern code and ship code that also works on older browsers, and for that we need a code compilation tool, also transpilation called. That simply is a tool which takes our code and transpiles it to code that also works on older browsers. Now, there, the most popular solution is Babel, but we'll not dive into this right now. Instead, we'll dive into this later in the browser support module, because there's a bit more you need to know about browser support and how to manage that before you can set up such a tool. Now, last but not least, you might want to check your code quality. So make sure that you follow certain patterns and conventions, that you consistently write your code in the same way. And for that, the most popular tool for JavaScript is ESLint, which you can also use. Now I'll walk you through Webpack, Webpack optimization, Webpack Dev Server, and ESLint in this module. As I mentioned, we'll have a look at Babel and this code compilation in the browser support module. Before we get started, let's see how we would combine these tools though. Well, the idea would be that when we write our code, we want to have two different workflows which we can start. We either have our development workflow, which should start whenever we save changes to our code, or our production workflow, which you typically want to start with a certain command, because that should not run whenever you change your code, but only once you're ready for it and you explicitly want to start it. Now, no matter which workflow we're in, we'll always need npm and Node.js. You might remember we installed that earlier already because we needed it to install that development server globally, and the development server in turn also requires Node.js to run. So this should already be installed globally. If not, make sure you do it. We do it together in this module because Node.js will be used by many of these tools behind the scenes to execute code on your machine and do these various optimizations. And npm is the Node package manager, which typically is used to install these different tools and also to orchestrate them, to start the different workflows, and so on. Now with that, let's see what we have inside of these workflows. Well, when we build for development, we want to have linting set up so that we basically can check our code and we always see if we have code quality issues in our code. We then, of course, also want to bundle our code so that we combine our different files into a couple of bigger files so that we don't send all these unnecessary HTTP requests. And we then want to have a development server which automatically reloads whenever our code did change. And that, in a nutshell, would be what we want to do when we develop and when we changed our code. Now, during production, we still might want to lint, but we're doing this all the time during development, so this kind of already should have been done by this point. But of course, we also want to bundle our code with the help of Webpack. We still want to ship a couple of files instead of dozens of files. Now, however, we also want to compile our code to translate it from modern JavaScript to JavaScript that runs in older browsers as well. But again, we'll cover this in a separate module. And once this is done, we want to optimize the code. Something we don't do during development because it can make debugging harder, but we definitely want to do it in production. Well, and then we have our production-ready code, which we get as an output and which we can now upload to the server where we need it. These are the two workflows, and we'll implement both in this module. Now, before we set up Webpack or anything, let's start with linting. And if you're using Visual Studio Code, the easiest way of implementing it is to install a certain extension. For that, you can go to View, Extensions, and in there, search for ESLint. Now, I already got that installed. You can simply install it there, and then you might need to reload your IDE, your editor. Once this is done, ESLint should be installed. Now, once it is installed, you can go back to the Explorer view here, and then to use ESLint, you can hit Command-Shift and P on Mac or Control-Shift and P on Windows and Linux to open up this command menu. There, you can type ESLint and then choose Enable ESLint. Now, here it's telling me that it already is enabled. Now, that doesn't seem to change much, right? I don't get any errors or warnings here. For the browser extension to work, we need to also install the ESLint tool globally on our machine or in this project. And here I want to install it specifically in this project. For that, quit that development server by pressing Ctrl-C here. And now in there, we need to make this project manageable by npm, which means I want to be able to install specific packages that are exclusive to this project. So I don't want to install them globally, but only inside of this project. And for that, we first of all need to create a npm configuration file to basically tell npm that this project should be managed by npm, and to then also manage our different dependencies, the different packages we want to use there. For that, you need to have Node.js installed. So visit nodejs.org, and if you didn't install it already, install the latest version of Node.js here. Simply download the installer, walk through the installer, works on Mac, Linux, and Windows, and once that is done, potentially restart your system if you're facing any issues with the next steps, and otherwise just execute npm init here in this project folder. I'm doing this with the help of the built-in terminal or a command prompt here in the IDE, which you can open with View Terminal. This is your normal system terminal or command prompt, but automatically navigated into this folder. Now, once you hit npm init, you're getting asked a couple of questions. For example, you need to define a package name, and you can confirm the default here, which you see in parentheses, by simply hitting enter. You can also enter an alternative value and hit enter to confirm that. I'm fine with the default here, also for the version. For description, you don't have to enter anything, but you can. Here, I'll just enter JavaScript, the complete guide, and hit enter. Entry point, doesn't matter, you can confirm this. Test command, you can leave that empty by hitting enter. Git repository, if you're asked, you can confirm the default or just ignore it. Hit enter. Keywords, you can ignore that, hit enter with no keywords. Offer, you can put in your name here or leave it blank. Hit enter thereafter. Confirm the default license, and in the end, once all of this is okay, simply hit enter again to confirm. With all of that done, you will have a package.json file, which you shouldn't delete. If you open that, you should see something like this. The settings you confirmed, basically. With that, this project here can be managed with npm, which means we can now install project-specific packages with npm. And there, I want to start with linting again. So we set up this project to have a package.json file to be managed by npm, therefore. We also installed the ESLint extension in Visual Studio Code. Now with that out of the way, we can install our first package by running npm install, a command we used earlier already, but now not -g, because I don't want to install it globally, but instead --save. Or to be precise, --save-dev, which basically signals to npm we want to install the following package as a development dependency of this project. Development dependency because it's not a third-party package which I want to use as part of my project. It will not be part of the code I want to upload to some server. It's just a package I need to do something with the code during development, to optimize it, to check it, anything like that. And then the name of the package here is ESLint, one word. That's the package we want to install. You can, by the way, always search for, in this case, npm ESLint, and find out the npm.js page about ESLint to read more about this package, about its usage, and so on. For this specific package, there's a lot you can configure, and I won't dive into all these details here, but of course, therefore, you have these official docs so that you can learn more about that. So let's simply hit enter now, and this will now install ESLint in this project here. Can take a while here, shouldn't take too long though. And once this command finished, you should see some output like this. And in package.json, you now have a dev dependencies entry where you see ESLint and the version number under which it was installed. This symbol here simply means that we're not necessarily focusing only on this specific version, which is the latest version at the point of time I'm recording this, but that we would be fine with this version or any version higher than that. We also have a package.log.json file which holds more detailed information about this dependency and all the dependencies of this dependency, and you can simply ignore that file, that package.log.json file. Now, important, you also now have a node modules folder. This folder holds the dependencies you installed, and that's why this folder is quite big, all the dependencies of this dependency, and the dependencies of the dependencies of the dependency, and so on. So we have a lot of packages in there, and in the end here we also see ESLint. Here you can see the code that the ESLint tool uses. It's all JavaScript code, but important to you, you should never change code in node modules. This is third-party package code, none of your business, we take it as granted. And this node modules folder is managed by npm. Indeed, you can delete it, and if you want to share your code, you always should delete it, and recreate it with npm install in your project folder. When you run npm install, npm will go into your package.json file, look at your dependencies and development dependencies, and install all the dependencies it finds there. In this case, ESLint and all the dependencies the ESLint package needs. And that's also where this version number then is important. npm install will install at least this version of this package because of this version number we specified here. So if I hit npm install, it again will go ahead and download all required packages, which in my case is the ESLint package. So with that, we have ESLint installed. How can we now use it? Well, for example, with our extension. For that, again, hit Command-Shift-P or Control-Shift-P to open this command panel. Type ESLint and choose Create ESLint Configuration. Now you get a couple of options down there in the terminal, and you can choose how you want to use ESLint. If you want to check the syntax, or if you want to check the syntax and also find problems, or if you want to do that and also enforce a specific code style. So you can basically choose how strict you want to be there. Now I'll go for the last option there, and now you have to choose if you're using modules and how you are using them. And we're using the default JavaScript modules import-export syntax. We can ignore the other option for now. We're also asked if we're using any specific framework, and we are not, so we can choose none of these here. If we're using TypeScript, the answer is no, so we can just enter an N here and hit enter. Where our code runs, it runs in the browser, so we select this option, hit space and hit enter. And then we can also choose if we want to use a popular style guide as a preset, so basically a code style guide defined and developed by other people. If we want to answer a couple of questions about our style to create our own guide, or if our file should be inspected so that a style guide is generated. Now I'll try this last option here. And I want to have a look at assets, scripts, app.js, scripts, app.js. Hit enter. We can then choose which kind of config file should be generated. I want to get a JSON config file. And after all of that, you should get such a ESLint RC JSON file. Again, of course, you can read all about how you can configure and use that in the official documentation, which you find on npm.js and in the resources linked to from that page. If we look into this file, we see this is the configuration that was assumed. It basically has a couple of rules set up now. And here, the rules part is indeed the most interesting thing. You see, there are a lot of rules here. Basically, a lot of things you can check for. And for example, in there, if we search for quotes, we see that for quotes, it accepts single quotes. Now, this means that if I go into my app.js file and I would use double quotes here, which is not a technical error, it would not like that. Now, how can we see that it doesn't like that? Well, simply reload your project, so close Visual Studio Code and reopen it, and ESLint should kick in. And here it's telling me that strings must use single quote. Of course, again, it's not a technical error to write it like this, but we're basically not following our own style guide. So therefore, I'll change this to be consistent again. It's also complaining about global this, which is not defined. No undefined variables must be used. Now here we of course know that global this is actually a reserved word which is available. We can click on quick fix for this and actually disable this specific rule for this line. This comment here is then added automatically and it tells ESLint, please ignore this line here. Or ignore this specific rule for this line here to be precise. Now we can also dive into our other files, and here for example we see that we got an unexpected blank line after a variable declaration. If we click on quick fix here, we see a lot of potential fixes. For example, if I click on the first one, you see that line thereafter simply was removed. Now, of course, if you're not happy with that rule to exist in the first place, you can search the specific error it's pointing at, in this case, the new line after var rule, and go into your ESLint RC file and search for a new line after var here and change this rule. For example, to change this to always. If you do that, this specific rule is gone because now we actually force a new line after every variable definition. Hence now in app.js I actually have an error here because I now don't have a new line here. So let me fix this here to always have a new line after we define a constant or a variable. Here it's now complaining about some trailing spaces, and therefore we can of course also get rid of that. So here we can also click on quick fix and fix this problem. Now in Analytics.js, we got more issues. For example, console log is not allowed because during production, it doesn't add much. Now here I actually do want to allow it. So I'll go back to ESLint-rc, search for no console, and instead of having error here, I'll set this to off, which means this rule is disabled. We're now allowed to do that. Here I get an error that I got a missing semicolon. Pretty good to have, so let's add one. And here it's complaining about some magic number thing. Now it might not be clear what this means, and therefore you can always click on Quick Fix, Show Documentation for no magic numbers. And we can then open that link. And on a new page, it leads you to the official documentation that essentially tells you that numbers like this are not allowed. It would be better to store them into a constant, timer, time, and then use that here instead, like this. Here we now also got an error that a new line is required. We can simply add a quick fix here. And here it's also complaining about a new line at once. Well, actually here, I don't want this, so I'll go to my function call argument new line rule here, copy that, go to ESLint-rc, search in that file for that, and change error to, control space, let's see our options, to off, to disable that rule. And with that, we fixed this file. Now we can do this for all these files, and as you see, there are a lot of issues. Now what you might want to do is, again, type ESLint in the command prompt and fix all auto-fixable problems. But even with that, you see we got a bunch of errors, because there are different rules which simply don't like a certain style. Now let me make clear here that this does not mean that our code is bad. These are just some defaults which are set up here, which are simply not fine-tuned to your specific requirements. We would have to go through, well, all or most of these rules, and instead of setting them all to error here, find sensitive defaults to see what we want to allow and what we don't want to allow. Now, it's not something I want to do here, because it's simply a task you have to do for your own. You have to find your specific code style. And therefore, what I will do is I will remove all these rules except for quotes, so that we force single quote strings, and simply get rid of all these rules. So mark all these rules here, delete them, also after this quotes rule, so that I have way less rules now. And if we do that, of course, well, we fix all these problems because we now have no ESLint rules there. Again, you might want to tweak this to your requirements, but you typically don't want to add all potential rules and set all of them to error, but add a couple of rules here which are important to you, like enforcing single quote strings, like enforcing a semicolon. And you can always add a new rule here with a comma, then double quotes, and then the rule name. You get auto-completion here as well, and you can check out the official ESLint docs. For example, here, if I search for a semi and set this rule, I can set this to error, and now we would get an error if we don't use a semicolon. So that's how you can manage your rules here. Again, official quotes and auto-completion here are your friend. And with that, you can really tailor your own code style and enforce it across your entire project. So that was linting with ESLint and the VS Code extension. Now let's move on to bundling, where we don't work on our code quality, but instead really on the code we output, so that we don't output multiple files where we need multiple requests, but instead we bundle our code together. So we added linting. Let's now have a look at bundling our code. So combine all these individual code files, these individual scripts, into one large script, so that we can write our code in a distributed way, so that we can write our code like this with multiple code files, but that in the end they are merged together so that we don't send all these unnecessary HTTP requests. And for that, we'll use a tool called Webpack. Webpack is a bundling tool. It's also more than that. It helps us orchestrate our entire build workflow, as you will see. But to get started, we'll just use it with its core task in mind as a bundler. Now, Webpack has a really good documentation at webpack.js.org. There you can dive into the docs, go through all these guides here to have detailed instructions on all the different things you can set up, dive into the different concepts to understand how Webpack thinks and what the different building blocks of Webpack are, and maybe also dive into the configuration to dive into all the nitty-gritty details you can configure. Because, and I will say this right away, Webpack is a complex tool. To get started with it, you don't need to configure much and will actually be able to do a lot with it in this module already. But to truly master it and fine-tune it for all the requirements more advanced projects might need, you should definitely check out this documentation, because you could easily create an entire course just on Webpack, and that's just not what this course is about. So we'll keep it fairly simple and focus on its core tasks, its core strengths. And for that, we first of all need to install it. So back in our project, open up this integrated terminal, navigate it into your folder therefore, and there we need to install Webpack again with npm as a development dependency of this project. For that, we run npm install --save-dev, and then it's Webpack and also one other tool, Webpack -CLI. So I'm installing two tools here, Webpack, and then unfortunately with a line break in between, Webpack -CLI. These two packages are getting installed now. Now simply hit enter, and this will now go ahead and fetch these packages, store them in the node modules folder, which we already talked about, and make them available to us. So let's wait for that to finish. It should finish without an error. If you're getting a warning in between, you can ignore that. In the end, it should finish with a message that looks something like this, confirming the versions that were installed. And it should update the package.json file to add these two new packages as a dependency. The exact versions, of course, will differ at the point of time you're viewing this. The idea behind Webpack and how you use it will not. So now we got Webpack installed. How do we now use it? Well, to use Webpack, we typically create a configuration file where we tell Webpack, that Webpack tool, what to do. For that, I'll add a new file on my top level next to the ESLint.rc JSON file and the package.json file. And this is a webpack.config.js file, not .json, but .js. This is a file which Webpack will use to do its thing, to do its job. And now here in this file, we have to provide a configuration for Webpack. Now this file under the hood uses or is executed by Node.js. We haven't learned Node.js yet, but generally Node.js is also just JavaScript with some extra features, but therefore you'll understand this syntax because, well, it's just JavaScript. The one thing which is new though is how we export something in Node.js world. Instead of using the export keyword to make something available outside of this file, we use module.exports and set this equal to a JavaScript object here. Now this is new, we haven't seen that before. This simply is the syntax Node.js uses for exposing this object outside of this file, and Webpack, the Webpack tool we installed, will go ahead and import this object. So this will be our configuration object where we configure Webpack. Now here I'm getting an error, module is not defined with the no undef rule, and we can quick fix this to disable no undefined for this line. Alternatively, we add the no undefined rule here and set it to off to disable it entirely. That's an alternative. This is what I'm doing here so that we don't face any issues with that. So now with that, I'm exporting this configuration object. Now Webpack needs to know where the starting point of your app is. So it needs to know where in your source files the entry point of your project is. And it will then take that entry point, in our case that would be app.js, analyze this file, most importantly, analyze the imports of that file, and then resolve all the dependencies of that file and the files related to that file. So in this example, Webpack would go into app.js, look at its imports, see that we import the project list, and therefore go to the project list file, look at this file's imports, and therefore see project item and the DOM helper, look at these files, and so on. This is what Webpack would do here to analyze your script and understand what's happening there. So therefore, we need to inform Webpack what our entry file is. And this now actually is the part where we will also need to reorganize our folder structure a little bit, because now we'll have to split it into our input source files and our output generated files. And for that, I'll add a new folder here and name it SRC. It's not a must use, but it's a convention to use SRC, which stands for source, as the folder that holds your input files. And then I'll grab the content of the scripts folder, so the app folder, the utility folder, and app.js, and drag that into source so that the scripts folder in assets is empty. So now this is dragged over here. And with that dragged over, we now want to specify this app.js file in the source folder as the entry point and specify assets, scripts as the output point, so to say. For that, we go back into the webpack config.js file, and now here in this exported object, you specify a entry key. And this can just be a string where you point at your entry file. It could also be a more complex object. You can also use multiple entry points, but here in this simple project and in many projects you're working on, you'll have one central entry point. So here we specify a relative path from this webpack config file to the entry file. So in my case, that's /, which means start in the same folder as the webpack config file, then source, and then in there, app.js. This is my entry file, and that's an important piece of information to Webpack. Now, besides the entry file, we also need to specify where the output should be written to. For that, we can add an output key here, and that can now be a JavaScript object where we, for one, specify the file name that should be generated. And here I'll stick to app.js, let's say. And the second thing is, of course, the path where we want to generate that file in. Now keep in mind, this will be our bundled code. This will be one code file in the end, which contains all the other merged code files. Now to generate that path here, we can use a utility module, a utility package built into Node.js, which you have available as well because you installed Node.js, and that's the path package. Now we need to import that package here, and if you import in Node.js, you don't do it with import, just as we also didn't use export to export something. Instead, you import like this. We want to use the path package, so we store it in a constant path, and we import it with the require function here, where we simply pass the package name to path, and path is a package built into Node.js. So this imports the path package and stores its features under the path constant. And now down there where we need a path, we can use path.resolve to basically build an absolute path with the help of that tool, where we want to start in our current path. And for that, Node.js has a global constant __ dir name. This simply gives us access to this current path where the config file lives in, and then comma assets comma scripts. What this does is it constructs a new absolute path, and output needs an absolute path, not a relative one, starting at our current file, so the absolute path to our current file, adding /assets to this path, adding /scripts to this path, so that in the end we generate our output here in the scripts folder. And now with that, if we save that, we have a basic Webpack setup. Now to use it, let's go to package.json, and there you have this scripts section. This allows you to set up some scripts which you can run through the command line. So here you can simply add a new script by adding a comma, and then between double quotes, any name of your choice. For example, build. Now then a colon, and then also between double quotes, the instructions you want to run. And there we can type Webpack, and this will use this Webpack CLI tool under the hood, which in turn will use the Webpack tool to do its thing. And Webpack will automatically search for such a webpack.config.js file, which is why it's important that you name it exactly like this, and take this configuration into account. So now we just have to save the package.json file, and now let's try running it with npm run build. This now starts Webpack, and here it actually quits with an error. Now you see, here, what it doesn't like is this projects equal thing here. It doesn't like this syntax. It tells us we might need an appropriate loader to use this JavaScript feature. Now, the thing indeed is that in project list and project item where we have this syntax, this is very new syntax, which at the point of time of recording this is not part of the JavaScript specification. It works in Chrome already, but not all browsers support it, and officially it's still in draft state, this class field syntax here. Which is why Webpack out of the box does not understand it and not support it. ESLint, by the way, also doesn't. I'm getting an error here. So this works, but it's on the edge, so to say, and therefore not fully supported by all tools yet. Now we could make it work with a so-called loader, but that is something I'll dive into a little bit later, also in the browser support section. And therefore for now the fix simply is to comment this out here and instead add this project as a property here in the constructor. We can also comment out this unused code here, by the way, to make this file error-free. This wasn't a technical error, but ESLint also doesn't like unused code. Now here in project item, it's the same. We can comment this out and instead add it here, has active tooltip, and set it to false. With that, let's retry this and let's rerun npm run build and let's see what we get. And again we fail, but now with a different error. If we scroll up a bit to the first red message, we see that it can't resolve project item.js.js. So indeed, and that's just something you have to know, Webpack as an extra utility feature doesn't require you to add the extension to your imports. We needed that when we ran the code like this in the browser, but Webpack actually just wants the import without any extension, and it then looks for files with .js at the end automatically. So the fix here is to go through all our files and remove the .js at the end. So here in app.js, I remove it at the end of the import in this file. Same in analytics.js. Okay, there we have no imports. Same for DOM helper. There we also have no imports. Tooltip, there I did have .js at the end, so I'll remove it there as well. Project list, remove it at the end as well. Same here. Project item, get rid of it there. Also here for our dynamic import, by the way. And that should be it. If we now save that, and we again run this, we get yet another error from the tooltip.js file, line 13, disclose tooltip function. If we have a look at the tooltip file, in the end, this is the same syntax I just removed before, where we have that cutting edge class field syntax, and that's the same here. This in the end is a class field where we store a function instead of another value. Therefore, the fix here as well is to get rid of it here and instead add it here with this .close tooltip. Let's save that and again retry npm run build. And now this looks better. We get a warning, we can ignore that for now, but what we also get are two files here in the scripts folder, in the assets folder. An app.js file, which is quite unreadable, so looks like we already got optimization going on, and a one.app.js file. Now, we get two files as output because I do have that lazy loading, as it's also sometimes called, in project item, where we only load the tooltip code when we need it. And therefore, this tooltip code and all the dependencies that only belong to the tooltip are packed into its own bundle, so that this still is only loaded when we need it, instead of upfront in one big bundle, so that we get the best of both worlds. Load some code only when we need it, but load the code we need right from the start in one go, instead of dozens of individual HTTP requests. That's why we have two bundles. Now, why is it looking like this then? Because Webpack by default built this for production mode and already optimized it. So let's see how we can change that. So we got our first Webpack build, we got the optimized code here, and we see why that's happening in our warning down there. The mode option has not been set, and therefore Webpack will use production as a default mode. So you can tell Webpack for which environment you're building, and by default it assumes that this is production. And if it is production, Webpack will automatically apply a couple of optimizations for you, which of course is really convenient. Here, however, I want to start with a development build, which does not do all these optimizations. And to tell Webpack that this is my goal, I just have to go to the webpack.config.js file, and in there, add a mode key and set this to development, like this. If you do that and you repeat this build command, npm run build, you see it again builds. Now we get this output here, and now you see here I got these files which are now not optimized anymore. The one app.js file is, 0 app.js was produced, and this is not optimized. Now what you also see is that, of course, there is a lot of extra code which we didn't write. And that's all Webpack's work, which in the end is the code that ensures that everything works, everything is loaded at runtime, and so on. Now, does that code work? Well, to find out, all we gotta do is spin up our development server again, which for now still is serve, by running serve. That gives us our web server at localhost 5000 by default, and visit this page and see what we got there. And if I reload, indeed, that looks good. Got no errors here. Got my working application where I can drag and drop stuff, and we're using app.js. So if I reload, you see we're only making one HTTP request here instead of dozens of HTTP requests. This one file is a bit bigger than all these single individual files, but that of course makes sense because it has merged all these individual files. If I click on the tooltip, however, this does not work. You see loading 0.app.js somehow fails. It does not find that because it's also looking in the wrong path here. It's looking directly in the root folder for this file, and that doesn't work because we know, well, actually that would be found in assets scripts 0 app.js. So this is something we'll have to fix. To work around this issue where we can't find this extra bundle, this extra script file which holds our tooltip code, we need to go back to our webpack.config file, and there in output, we need to add one other key, and that's the public path. Now, the thing is, Webpack is taking all our input, bundling it up, and then moving it into this assets scripts folder. Our web server then imports app.js from the assets scripts folder. The problem just is that Webpack writes our app.js file such that it looks for the 0 app.js file in the end not in the same folder as the app.js file is, so not in the scripts folder, but on the root level of our server. And that's what we can change with public path. We in the end can tell Webpack here that our files are stored in a different path. For that, we can set the public path here to assets/scripts/ in my example here. And then quit the development server here with Ctrl+C, rerun npm run build, and then rerun serve to bring up that development server again. If we now go back and we reload here, if I click on more info, this now works and loads this file correctly. So now this is working and we're able to get our tooltip to show up, and we got our bundled output which still supports this capability of loading some code on demand. So now we got the Webpack basics set up. We're able to create our output here. Now, what we don't have is that development server that would automatically reload whenever we change something. And that would be nice to have. For that, we have to install an extra package with npm install --save-dev, and that's webpack-dev-server. Hit enter and install this package, again, locally into this project as a development dependency, and we can then use this dev server to, well, serve our application. For that, let's go to webpack.config.js file, and there, maybe after output, you can add a dev server entry. The exact order of configuration options here doesn't matter, by the way. And dev server can be an object where you set a content base key. This tells dev server where your root HTML file can be found. And here, that's just // it's the same folder as the config file. Therefore, you actually also can omit this setting here altogether. It will just work because that will be the default anyways. So now to use that dev server, we can go to package.json and tweak our script. We got the build script here. Now let's also add a build :dev script maybe. You can again name this however you want. And there we run webpack-dev-server like this. And this again will take our Webpack config into account and will do all the Webpack things, but it also launches a development server that's tied to the output. So if we now run npm run build :dev here, this should spin up that development server and still do our build, but now this is a process which keeps on running, and you should keep this running until you're done for the day, at which point you can always quit it with Ctrl+C, and then you can always restart it by executing that command again. As long as this is running, it watches for changes in your entry file or in any file associated with that, and it will rebuild whenever you do change something there. You can visit your page on this address, which it outputs up there, in my case localhost 8080, and therefore now if I enter this here, I get the same running project. Now let me show you that live reload which I meant. If I go into, let's say, the project list file here, and I comment out this console log and save, you see it recompiles. It did find out that project list changed, and it also reloaded the page here. Now how do I know that it reloaded the page? Because the console here has a new output, different from before. It's not printing the output from my project list from line 25 anymore. That's not happening, as you see here. Now, of course, we don't need serve anymore, but instead we can just use this Webpack dev server, which automatically rebuilds whenever we change something, and which therefore, of course, gives us a very convenient development experience. Now, what about debugging? What if I want to debug my code? Well, if we go to the Sources tab and you check out Assets, Scripts, you'll find a file which is pretty hard to debug. All the Webpack code is in there, and it's pretty impossible to debug your code there. But you should also have a Webpack folder here, so to say. There you should find a dot folder, and there in Source, you find your original code files. At least mostly original. But these are also tweaked by Webpack, and the app.js file is empty. So this is better for debugging, but still not ideal. To get a good debugging experience, we need to go back to the webpack.config file, and there add a so-called devtool. Add the devtool entry here, and now you need to pass in a string here, or provide a string, where you use one of the provided development tools, which in the end just means how Webpack links your file to the original code, you could say. So how well this is from a debugging experience. There you got different levels of detail, and the better the linking, the slower the build process, and so on, the bigger the output. So for development, you want to have good linking for good debugging. For production, you of course want to minimize this to have as small of an output as possible and to also speed up the build process. So which options do we have here? We can find that in the official docs. There, under guides, if you click on development, you can click on using source maps, where you can learn more about that. And then here, click on different options. There you see all the built-in dev tools, and you can check out this table to find out which one works best for you. Here I'll go for cheap module evil source map, copy that and enter it here in this string. And now if we save that, we have to restart our build dev process to take the new configuration file into account. And with that done, if we go back to our project and reload there, you should find that in the Webpack folder, in the dot folder, now in the source folder, you really find your original code here, if you inspect these files, and you can also place breakpoints there. For example, if I go to project list here, and there to the drop event listener, and we add a breakpoint, then as soon as I do drop, we indeed pause here, and we can do what we can always do here. We can do everything you learned in the debugging section. So now we have a great setup for development, and we can now also debug our code. And with that, we bundle our code, we have the development server, and we can also debug our code, and we have a good development experience. We also added linting, which you can of course also fine-tune to your requirements regarding the rules you use there. Now what's missing is that we also have a finished production workflow, where we optimize our code and spit out as small of a code base as possible. Let's do that next. So with the development part out of the way, let's now build for production. Now, for production simply means that we want to spit out optimized code, that we don't want to have such a detailed source mapping so that finding our original code is harder, but that's not the main reason, because people will always be able to read our code if they really want to. But instead, we just want to speed up that process, and we want to make sure that the output files are as small as possible. Now, for that, to make that happen, we need a different config file for production. So I'll add another webpack.config file. However, I will name it .config.prod.js. And this will be our config file for production. Now we can copy the code of our other config file and move it into this prod file, but there switch mode to production, leave entry and output, that's the same, but change the dev tool here to a production ready one, which we can find on the table here. There we see for production, we can either set this to none, to an empty string, or omit this setting, or use something like cheap source map, which is what I will use to have some source mapping, because sometimes you also want to debug your production code if you detect a bug on the running web page. But with that setting, we have a bit worse source maps. Debugging will not be on the same level as before, but at least we can look into our code to a certain level. So let's save that. And with that, we're generally ready for production, or for building for production here. Now we can add a new script here in package.json, maybe build::prod. And there, I don't want to start the dev server, because I don't want to run this on a server all the time. Typically, you don't want to test your production code that much. You test during development after all. But instead, I just want to generate my output assets. For that, we can use Webpack again. But now we need to tell Webpack which config file to use. For that, you just add --config after Webpack and then point at the config file that should be taken into account. By default, it will always look for webpack.config.js, but we can change this by pointing at webpack.config.prod.js. And therefore, of course, you could have used any file name as long as you pointed at it. If we now run npm run build::prod here, it will build our code or our project for production and output that here in the assets scripts folder. So now this is what we get there, our optimized code, as you can tell. Now let's still test if that works, however, by running serve now, our other development server. And therefore, let's visit localhost 5000. And this is still looking good. Looks like the entire application works as it should. Now with our production ready code, as you can see if you go to the network tab and you inspect one of these files. This is actually reformatted by Chrome to be more readable. The original code looked like this, and this certainly is our production code. So now we also build for production, and therefore we have two workflows now. One with this build dev script, which spins up the development server, which we use all the time whilst we're writing code, and one which we use right before we're ready to deploy our scripts, to use our scripts on our page. And we typically run this build prod command whenever we have a new change finished, a new version finished, and we now want to build that, output it, and push it to our servers. Now with our two workflows set up, we're generally done, but there are two improvements I want to implement here. One is our assets scripts folder. It grows and grows, and whenever we build something new and files are named slightly different, the old files are kept around and the new files are added. Now, this is not ideal. Instead, I would want to clear my scripts folder with every build and then just add the newly generated files there to get rid of the old files, which I really don't need anymore. And that's easy to do with Webpack. We just have to tweak the configuration a little bit. We have to install a new package, first of all, with npm install --save dev, you know that. And then it's clean-webpack-plugin. This installs a new package which we can implement in our Webpack config, in our Webpack workflow, that cleans up the Webpack output folder, so the path you're specifying here, in our case assets scripts. To use it in the Webpack config file, I just have to import it, again with this const syntax. Clean plugin could be a name you want to use there, and require clean webpack-plugin. Now, clean plugin can be used in our webpack config file. We just have to add a new entry, a new config item there, which is called plugins. Now, plugins is a concept in Webpack which allows you to apply various optimizations or transformations on the generated output, so to say. So not on the individual files, but on the generated output, or in case of the clean plugin, on the output folder before the output is written to it. Plugins is an array because you can apply more than one plugin, but here I only need one plugin, and that's my clean plugin. For that here, for this plugin, we create new, then clean plugin dot clean webpack plugin, and execute this as a function. So we create a new object of that type, so to say. In case you're wondering how I know this, from the official docs. You learn all of that in the official docs, and the docs really are the place to learn this. Now, of course, I don't just want to add this here in the normal Webpack config file, but also in the prod file. So there, let's also add a comma after DevTool and add plugins, and of course also add the import here. So copy that from Webpack config into Webpack config prod. If we do that and we repeat npm run build prod, we'll see that our scripts folder now is a bit emptier because all the unused files were deleted, which is indeed what I want. So that's one nice thing, that's good to have. That's one useful improvement. Another improvement is the naming of these files. I'm generally fine with these names, but if you would deploy these files to a server, so if you take your web page, your HTML files, and the scripts that belong to them, and you move that onto a server and users start visiting your page, then browsers will typically cache JavaScript and CSS files, which means they store copies of these files, and if the file hasn't changed the next time the user visits a page, they will keep that stored, that cached file. Now, that is an improvement which often makes sense, and you can control it from a server side by setting the right headers on your resources, which is a server admin task and not really directly related to JavaScript. But you can also force browsers to download a new version of a file by simply changing the file name, because then it's a new file to the browser and it will therefore download it and not use any cached version. Now for that, we want to generate these file names automatically and generate a new file name whenever we produce a new build. And that's something where Webpack also helps us. It makes it easy for us to add not a random, but a deterministic but unique element to every file name, which changes with every build. For that, all we have to do is go to our config, and there, let's say to our production config, because that really only matters for our production output. And there in the output config, in the file name, we can add a dynamic element. We can add square brackets here, like this, and there enter content hash. And it has to be written like this, because this is a keyword to Webpack, which tells Webpack that a hash should be generated here. A hash that is different whenever a file changed. If a file didn't change, Webpack will keep the existing hash. If we do that and we save this, you'll see what I mean when we rerun npm run build prod. If we have a look at our output in the scripts folder, you now see we have names like this. So this is now an output which will change every time we change the underlying files and we rebuild. And therefore, since the file name now changes, browsers will re-download these files. Of course, we now just need to make sure that in our index.html file, we update this import to meet our latest hash here. Only for production, however, because if I go back to dev, then this will not be the case. Their output files are actually not written to the scripts folder, which is why it's now empty, but instead stored in the memory. But they also wouldn't be renamed because in the Webpack config file, which is used for development, I'm still using app.js as an entry file. So there, if we test this during development with the Webpack dev server at localhost 8080 here, it still works as before. If we build for production, however, we get our output files in the scripts folder, and then they will have these dynamic names. Then we'll just have to adjust this name here in index.html, and then we can take our code and upload it to some server to have the changed file names if our content changed there, and we therefore want to reflect this on our server and force browsers to take the latest version of our scripts. And that's the final optimization I wanted to implement here to make sure that we really produce output which is production ready and could now be pushed to a server. Something we'll, by the way, also do in the deployment section of this course. Now we're done for this module, but here's a little bonus. With our enhanced project setup now, where we use NPM to manage our development dependencies and Webpack to bundle our code and the Webpack dev server, we now also got a new way of adding third-party packages. Let's take Lodash again as an example. You saw that in the libraries module. Here I will add it again. Now in the libraries module, I showed you that you can download the script or fetch such a CDN link and add all these imports in your index.html file. Well, now that we actually use NPM and bundling, we got a third way of adding Lodash or any other third-party library basically. We can scroll down to the installation and there we see that with NPM, we can actually install Lodash with this command. So let's copy that and execute it here in the terminal, navigate it into our project folder. It's npm I, which is just a short form for npm install, -- save, not save dev, because it's not a development dependency, but actually a dependency which we need as part of our final code, which we ship. And then the name of the package, which is Lodash. Now if you hit enter, this is getting installed, and once this process finished, it will for one be added to the node modules folder, and you also see you now have a new dependencies entry with Lodash as a dependency in your package.json file. Now that alone does not add it to your project though. It just added it to your folder but not to your web application, to your script. If you would want to use Lodash though, let's say here in the app.js file, you can now import it. The convention is to import third-party packages first, but that's not a must-do. And you can import it as shown here, with this required syntax here in Node.js, but actually also with another syntax, which I want to show you here. You can import everything as, let's say, underscore, to keep that special variable name Lodash uses, from Lodash. Now here we don't have a relative path to any file. Instead, this is simply an instruction Webpack will understand when it analyzes our imports. And if you have a path or a package name like this, which is not a path, so which does not start with ... or /, then Webpack will go ahead and look for a package with this name in node modules and import the package from the node modules folder. Now here I'm storing everything in this underscore symbol, and therefore here we could try to console log Lodash difference between, let's say, 0.1 and 1.2. And with that, what we would do is we would run a similar example as before, but now with Lodash imported differently. If we now run npm run build :dev again to restart our development server, this should work and should include Lodash into our bundle. So if I reload my page here, indeed it works, and this is the output I'm getting from my app.js file related to that Lodash code. Now, some libraries, and Lodash is one of them, also offer some improved imports to not import everything, because if you just import from Lodash, you import the entire Lodash package. If you're only interested in some features, you could import from Lodash/array, for example, to only add array functionalities, and difference is an array functionality. So now this would still work, as you can tell, but we would actually import less and therefore have a smaller bundle. It always depends on the exact library you're working with. Each library has its own import syntax you can use, and the official documentation is typically the best way of finding out how you can add this library to your project and how you can import from that library. And that's it for now. Now we're using Webpack to bundle our files, to optimize them, to have a dev server. We're using ESLint to, lint our files. And of course there, you can configure this to your requirements, to your needs, with the help of the official docs also, as I mentioned. And we now therefore have a setup where we're able to write our code in a way that works well for us developers, in a way where we can split our code across multiple files, and where we then still produce output which is optimized and which also is bundled together to minimize the amount of HTTP requests. And still, features like this dynamic request for more here for this tooltip JavaScript file, which is only needed eventually, still works. So that all is supported by Webpack. A very powerful tool, therefore, with which you of course can do more. The docs are very long, there's a lot you can tweak and manipulate there. So definitely dive into this documentation if you want to learn more about Webpack and what you can configure there. You can fine-tune it in a lot of different ways. Also, one thing which we haven't done at all right now is we haven't used loaders in Webpack. Loaders allow us to transform files, and that allows us, for example, to use next-gen JavaScript features when we write our code and still produce code that does not use these features and works on older browsers as well. And this is a pretty exciting technology or thing we'll explore in the browser support module.